This is Lesson 3-7, Functions and Graphs. The Westerville Marching Band is going on a year-end trip to an amusement park. Each band member must pay an admission price of $15. In the table, this is represented by the algebraic expression 15m. Copy and complete the function table for the total cost of admission. 15 times 3 would be $45. 15 times 4 would be $60. 15 times 5, $75. And 15 times 6, $90. Graph the ordered pairs, number of members, total cost. So the number of members would be the input value or the x value. The total cost would be the output value or the y value. And you can see they're graphed here on my graph. Here's one student at $15, 2 at $30, 3 at $45, 4 at $60, 5 at $75, 6 and $90. Notice that they appear in a line on the graph. If you're given a function, ordered pairs in the form input and output or x and y provide useful information about that function. These ordered pairs can then be graphed on a coordinate plane and form part of the graph of the function. The graph of the function consists of the points in the coordinate plane that correspond to all the ordered pairs of the form, input and output. In this example, the table shows temperatures in Celsius and the corresponding temperatures in Fahrenheit. Make a graph of the data to show the relationship between Celsius and Fahrenheit. Again, the input is the x value, the output is the y value. The ordered pairs then are 541, right here, 1050, 1559, 20 and 68, 25 and 77, and 30 and 86. The table shows the money remaining on a $75 gift certificate after a certain number of CDs are bought. Make a graph to show how the number of CDs bought and the remaining balance are related. Again, the number of CDs is the x value, the input, the balance is the output or the y value. The solution of an equation with two variables consists of two numbers, one for each variable, that makes the equation true. The solution is usually written as an ordered pair x and y. And again, in this case, you can see the ordered pair 163, 251, 339, 427, and 515. Again, all in a straight line. Graph the equation y equals 2x plus 1. Select any four values for x. We chose 2, 1, 0, and negative 1. Substitute these values for x in the function rule. Perform the function rule and get the output, which is the y value, giving us the corresponding ordered pairs. As you can see, those are graphed here. 2, 5, 1, 3, 0, 1, and negative 1, negative 1. The four inputs correspond to the solutions 2, 5, 1, 3, 0, 1, and negative 1, negative 1. By graphing these ordered pairs, you can create the graph of y equals 2x plus 1. In this example, we have the equation y equals x plus 3. And again, we will substitute 2, 1, 0, and negative 1. So 2 minus 3 is negative 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. And negative 1 minus minus 3 is negative 4. So ordered pairs are 2, 1, or negative 1, 1, negative 2, 0, negative 3, and negative 1, negative 4. So let's graph those points. 2, negative 1 would go right here. 2, negative 1. 1, negative 2. 0, negative 3. And negative 1, negative 4, giving us this line. In our next example, we will graph the equation y equals negative 3x. In this case, we will use 0, 1, 2, and 3. So 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So our ordered pairs would be 0, 0, 1, 3, 2, 6, and 3, 9. 0, 0, 1, 3, 2, 6, and 3, 9, like so. Which gives us that line. In this example, the equation is y equals 3x plus 2. We will use negative 1, 0, 1, and 2 for our values for x. So 3 times negative 1 is negative 3 plus 2 gives us negative 1. 3 times 0 plus 2 is 2. 3 times 1 plus 2 is 5. 3 times 2 plus 2 is 8. So negative 1 is our first ordered pair. 0, 2, 1, 5, and 2, 8. So negative 1, negative 1, 0, 2, 1, 5, and 2, 8 would give us this line, like so. Notice that all 4 points in the graph lie on the same line, same straight line. Draw a line through the points to graph all solutions of the equation y equals 2x plus 1. Note that 3, 7 is also on the line because when we substitute 3 and 7 into our equation, we substitute 3 as the value for x. We multiply that times 2, add 1, and we get 7. So that tells us that the ordered pair 3, 7 is also a solution to the equation y equals 2x plus 1. The equation y equals 2x plus 1 is called a linear equation because its graph is a straight line, as have all the graphs in this lesson been. Michael Phelps swims the 400-meter individual medley at an average speed of 100 meters per minute. The equation d equals 100t describes the distance that he can swim in t minutes at this speed. Represent the function by a graph. This is the input. This would be the function rule right here. D would be the output, and this would be the ordered pair represented by the input and the output. You can see that those have all been graphed. 1, 100, 2, 200, 3, 300, and 4, 400. Again, forming a straight line. Sandy makes $6 an hour babysitting. The equation M for money equals 6H for hours. Describe how much money M she earns babysitting for H hours. Represent this function by a graph. Well, if she works 1 hour, she makes $6. 2 hours, she makes $12. 3 hours, she makes $18. 4 hours, she makes $24. M equals 6H. Our input, X value, 6H, and Y is our output. 6 times 1, 6. 6 times 2, 12, and so on. There are 12 inches in 1 foot. The table is feet to inches. We're converting from feet to inches. Our equation is F equals 12N, where F represents the number of feet and N represents the number of inches. Again, these then would represent our ordered pair. 112. Here's 112. 224. 336. And 448, again giving us a straight line. Graph the function represented by each table. Here's the graph represented by our first table. You can see that the input is 1, the output is 4, the ordered pair is 1, 4, the input is 2, the output is 8, the ordered pair is 3, 8, and so on. The input is 3, the output is 12. All of those points would be on this line. In our second example, converting minutes to seconds, the input is 1, the output is 60, represented by the ordered pair 160. The input is 2, the output is 120, represented by the ordered pair 2, 120. The input is 3, the output is 180, represented by the ordered pair 3, 180, and so on. 4, 240 would also be on this line. The equation y equals x minus 1. Let's use negative 1, 0, 1, and 2 for our values for x. So negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. So our ordered pair is negative 1, negative 2. 0, negative 1. 1, 0. And 2, 1. So let's graph those. Negative 1, negative 2 would be right here. 0, negative 1 right here. 1, 0. And 2, 1 would be right here, represented by the line that passes through those 4 points. Y equals negative 1x. Let's do 1, 2, 3, 4 for our values for x. So negative 1 times 1 is negative 1. Negative 1 times 2 is negative 2. Negative 1 times 3 is negative 3. Negative 4, or negative 1, excuse me, negative 1 times 4 is negative 4. So our ordered pairs are 1, negative 1, 2, negative 2, 3, negative 3, and 4, negative 4. So our ordered pairs would be 1, negative 1, 2, negative 2, 3, negative 3, and 4, negative 4. And this would be the line represented by that particular equation. Y equals 2x minus 3. Let's do negative 1, 0, 1, and 2. So 2 times negative 1 is negative 2 minus 3 is negative 5. 2 times 0 is 0 minus 3 is negative 3. 2 times 1 minus 3 is 2 minus 3 is negative 1. 2 times 2 is 4 minus 3 is 1. So our ordered pairs are negative 1, negative 5, 0, negative 3, 1, negative 1, and 2, 1. So negative 1 and, negative 1, negative 5, 3, 4, 5, 0, 3, or negative 3, 0, negative 3. This one actually has to go down one more to get to negative 5. Our third one is 1, negative 1, and our fourth one is 2, 1. So this would be the line described by that equation. Like so. The perimeter of a square is 4 times greater than the length of one of the sides. The equation P equals 4s describes the perimeter of a square with sides s units long. Represent this function by a graph. P equals 4s would be the same as x, or y equals 4x. Be the same type of equation, y equals 4x. So if we have a side of 1, we have a perimeter of 4. If we have a side of 2, we have a perimeter of 8. If we have a side of 3, we have a perimeter of 12. If we have a side of 4, we have a perimeter of 16. So let's graph the ordered pairs 1, 4, 2, 8, 3, 12, and 4, 16. If we can get those to fit on our graph, we have 1, 4, 2, and that's about all it's going to fit, but that should be enough to graph. If we go up here to 3, 12, should look something like that. Our line would look like so. We want to make sure it passes through our 2 points that we've got graphed already. That would mean that this point should be over a little bit like that. A linear equation is an equation for which the graph is a straight line. At this point, you should quit watching the video, go to my Lesson Quiz 3.7 on my Moodle page, type in your username, which is your 6-digit student number, and your password, which is the first 6 digits of your last name, and your 2-digit